Hello, everyone. Thank you for joining us this evening, whether on YouTube, Facebook, or Twitter. My name is Melissa Hosick. I'm the adult programming librarian here at the East Brunswick Public Library. Thank you for joining us for our second New Jersey Makers Day program for 2022 on 3D printing and space. For the full list of events, you can go to ebpl.org/maker. And you got to check it out. We've got cool stuff throughout the month. But without further ado, I'd love to introduce Isaac. Isaac Osores is an East Brunswick resident. You'll see him around the library, actually, who enjoys amateur astronomy, 3D printing, and tinkering with Raspberry Pi boards. He is a NASA Solar System ambassador committed to communicating the science and excitement of NASA's space exploration missions and discoveries with people in our community. So thank you all for joining us. When you have any questions, please place them in the chat wherever you find that, and he'll answer them at the end. So take it away, Isaac.
Hi, everyone. My name is Isaac Osores. I'm an East Brunswick resident, like Melissa mentioned. Today, I'll be talking about 3D printing and space. So let's get started. Just a quick agenda. I'll be going through a quick introduction of myself. What is a solar system ambassador? What is 3D printing? Some 3D printing and filament types. And then what does it look like to take something from concept to reality using 3D printing? I'll go into a brief history of 3D printing in space, about the Future Engineers 3D Printing in Space Tool Challenge that happened a couple years ago, and then also go over current applications and the future implications of this technology. I included some resources to take away, and then we'll get into questions and answers. So a quick introduction of myself. My name is Isaac Osores. I'm an East Brunswick resident. I've been here for about 7 going on 8 years now. And as Melissa mentioned, I'm a 3D printing hobbyist. I've been printing for the last 5 years from home and just find the technology very, very interesting. I just love the idea of being able to take something from an idea to a reality, to something physical that I can hold in a matter of hours. So I'm really joyed and happy to talk about it today. I'm also an amateur astronomer. I love taking the telescope out into the yard and taking a glance at Saturn, Jupiter, their moons, and even our moon. And as Melissa mentioned, I do like tinkering with Raspberry Pi computers. And if you're not familiar, they're just tiny computers the size of your palm that you can do pretty powerful things with. And if any of those things interest you, I've included my QR code to my Instagram page where you can keep up with my projects, see what's going on my side, and just take a look at any astronomy pictures that I take. I like to post them there. My handle is 3D Astro Geek on all platforms, whether it's Facebook, Instagram, TikTok, Twitter, etc. And then I am also a NASA Solar System ambassador. And you're probably wondering to yourself, what exactly does that mean? Especially if you did not attend my last presentation about telescopes. So I included a slide on what the program is. In essence, it's a program of public engagement that works with volunteers like myself to communicate the excitement and science of NASA's space exploration missions and discoveries with our communities. And some of the events that I've done with the library, like last year going over telescopes, the different types and what's in the night sky, is an example of an outreach event that I've done. I was also present at the East Brunswick Day last summer. Events like those are things that I'm excited about. And if you have any questions about today's presentation or any future events that you'd like to talk to me about, you can scan the QR code or go to the URL here. This is my bio page on the NASA site, which also has a contact me button. So you can click on that and send me a message and we can get started talking about anything that might interest you. So without further ado, let's get into the meat and potatoes of this presentation and go over what is 3D printing. 3D printing, as defined, is the process of making a physical object from a digital one, a 3D model. But how does this happen? We have this 3D model here. This is a AA battery dispenser that I found on thingiverse.com. How do we take that and actually make it into something physical? Well, if you look at the video on the right, you can see the 3D printer prints this model layer by layer. And as I put there, it does this by adding layer upon layer of material until the object is complete. This is also known as additive manufacturing. As the name applies, you're just adding layers upon layers of, in this case, plastic until you have your finished product. Now, there are a variety of different types of 3D printing, and we were remiss if I didn't mention at least some of them. Now, I won't go into too much detail about these next ones, but I figured at the very least I could mention them. One is vat polymerization. This uses light to cause a photochemical reaction to adhere resin, again, layer by layer. So if you look at the diagram, you have a light source that is being reflected off a mirror and then goes to a particular location. By going through this process, the resin becomes solid, and layer by layer, the solid resin is risen on this platform until you have your finished model, in this case, a letter X. Another type of 3D printing is powder bed fusion, PBF. And this one is something similar where it uses a light source, but in this case, it uses a high power density laser to melt and fuse metallic powders together. So again, you have that light source, the mirror, which focuses the laser on a particular point and fuses the powder together bit by bit, layer by layer. And once it's done with one layer, more powder is added on top, and then the process continues again, and it does the next layer. And it does this, of course, until your, I guess in this example, Model X is complete. But really the one we'll spend a lot of time talking about here today is fuse deposition modeling, FDM. This is one of the more common types of 3D printing. It uses thermoplastic filament material heated through an extruder to be deposited precisely on the print bed. So here in this model, you can see the blue line of filament being fed into the extruder. And depending on the type of filament and material, the extruder would be heated anywhere between 180 degrees Celsius and upward to then print precisely and lay down layers of plastic where it needs to go as it builds, in this example, Model X. It does this until completion, and there you have your physical object. Here's an example of an FDM 3D printer. This just happens to be the one that I own and is situated right next to me on my desk. This is a Lulzbot Mini version 1. I've had it for about 5 years now. And as you can see, I have a spool of filament at the top there. And it's hard to see from the picture, but I took a little bit of filament out of one of my spools, and you can see it's just like you could imagine a thread, but it's just plastic of a given diameter. Thank you, Melissa. So that spool there that I have in the picture is white, PLA, and it feeds into, if you follow this cursor, into the extruder, which is here. Now this block would heat up and then lay down the filament layer by layer. And of course, it uses motors to move the heated extruder left and right, the red, left and right across axis there, and then up and down. It does have other motors that control its height. Additional motors move the heated print bed, which is this dark orange looking square. And this one moves back and forth or in the y-axis. So there you have your 3 dimensions for 3D printing. And of course, it's through well choreographed movements that a 3D object is made. And while we're on this slide, I'll just mention really quickly, I do have additional things on my printer where you can see this cable to this light ring and this camera. I have a Raspberry Pi computer hooked up to my printer so I can manage it remotely. It just makes things a lot easier. But then also I get the benefit of being able to take videos of my 3D prints, just like in that first slide that went over what is 3D printing. So I can create time-lapse videos, or I can just remotely check on the status of a print and see how it's doing. Does it look okay? Should I quickly cancel it because something went terribly wrong? I have that capability because of that Raspberry Pi computer to do so. Moving forward, we can talk about different types of filament that can be used on these types of printer. There's a large variety of filaments that are out there. So this list that I have here is by no means the definitive list. We have different types of plastics, such as PLA, PETG, ABS, and TPU. Your typical filaments, plastic filaments to use are PLA, PETG, ABS, if you want to create something a little bit more sturdy and hardened. And then TPU is actually more of a flexible filament. And I actually have an example here of something I printed in a TPU filament material. And it's actually the symbol pi. So just in time for Pi Day, this upcoming Monday, 3/14. And as you can see, it's very flexible. I can, mess around with this a little bit and it retains its shape because it's made in that material. If I took something maybe printed with PLA, it might be a little bit more rigid. It might have some way, but it won't be as flexible as TPU. So that's one example there. Then, of course, we have metal-filled copper filaments, and these can be anything between copper, bronze, steel, and so forth. And I included an example here, the bottom left corner. This statue was actually 3D printed using the copper filament. And as you can see, it has a nice shiny finish, but also they de-aged it a little bit. So depending on what you're looking for, you certainly want to think about what kind of filament you should use as to give you that nice finish that you're looking for in the end. There's also wood-filled filament, some of which use pine wood, cork, and other materials. I've even seen cherry. So again, going back to that look and feel that you're looking to have with your 3D prints, by all means, consider the filament that you use. And that example being, of course, the owl that we have here for the wood filament. And then beyond that, you get into the more fancy types of filaments where it can glow in the dark or it can change color. And that's an example that we have here in the upper left corner with this chameleon print. This one is reactive to temperature. So if it's out in, let's say, direct sunlight, it'll heat up and change color. Or if you bring it back inside and maybe cool it down somehow, it'll go back the dark green color instead. So there's definitely a wide array of options that are out. You just have to find what it is you're looking for and print with it. So now let's talk about how do we take the concept and bring it into the real world, something tangible. It really can be done in 3 steps, granted, very level 3 steps they are. The first one being you can either create or pick the 3D model you'd like to print. So you can search sites like thingiverse.com that I mentioned earlier, which is where I got this AA battery dispenser. Or if you're capable and would like to play around with tools such as Tinkercad or Fusion 360, you can by all means design your own 3D model to print. But for this process, we'll stick to the AA battery dispenser. And I included the link there if anyone's interested. It's actually pretty useful. For step 2, it really is a matter of loading the 3D model you are looking to print into a program called a slicer. And examples of a slicer program are Cura, Simplify 3D, or literally with a 3 instead of an E. Very creative. And as the name implies, what this program will do to the 3D models is essentially it takes the model and slices it into different layers. And it actually helps tell the 3D printer exactly where it needs to go, how much filament it needs to deposit, and do that for each and every layer that the 3D model has. But what's nice about a slicing program is you can actually customize the print settings. So something like layer height is something you'll hear in 3D printing circles. And that comes down to is the quality. So a larger layer height won't give you the resolution that a finer, lower layer height will give you in terms of quality. You can also change the infill settings as to how solid does this object need to be. Does it need to be flexible, so maybe not completely filled in all the way? Or does it really need to be strong and sturdy and be completely filled in on the inside? You can also mess around with the scaling. So if I wanted to take, say, from a couple slides ago, the 3D model of myself, I can go ahead and scale that to whatever size I want. I can print this in this size that I have here, or I can print it as big as my 3D printer can manage and just have that laying around to creep out my wife. But in slicing program is where you can make all these changes. And once you're set with the settings that it produces a file, a G-code file. And this is where all the instructions are essentially saved that tell the 3D printer where to print, how much to print, what temperature to set the extruder and the heated bed, and everything in between. And then finally, step number 3, we just take that G-code file and send it to the 3D printer and we wait. So one of the most common ways to send the file to the 3D printer is by saving the G-code file on a memory card and then taking it to the 3D printer and loading it that way. But as I mentioned earlier, I have the capability of remotely managing my 3D printer thanks to my Raspberry Pi, which is running Octoprint. And I can do that from the couch upstairs and not have to walk down the stairs back to the printer, load the file with a memory card, and then set it. I can do that from the couch upstairs and then set the video settings as to how I want the time-lapse video to look like. So if you look here, that's exactly the same video we had earlier, but I set my time-lapse video to set the extruder to the back left corner and then take a picture every layer change. And so it did this. And this print in particular took 6 hours to complete. That's one thing that you won't really hear about too often, which is the speed in that 3D printing takes. 3D printing is a very long process, especially if you want finer detail and smaller heights, right? If you're in smaller layer heights, then it's obviously going to take a lot longer to print, but that's sort of the trade-off that you need to consider and make. Do you want to wait that long, or do you not really care about the quality? But essentially, those are your 3 steps to take that AA battery dispenser from that 3D model on that website to an actual one that you can start loading batteries and organize your shed. Great. So now that we have a good baseline on 3D printing that's available, a 3D printer and how it works, and the different types of filament, we can jump into a very brief history of printing in space. So I will pose this situation to you. Suppose you are an astronaut on the International Space Station, or ISS, and you need a tool. How does that tool get to you? Well, of course, it could have been packed as part of your initial trip to the ISS, but space is limited, and you might want to have spares, right? If something happens to the original, that ends up becoming, considering all the different equipment that you need to take up with you and having spares, that takes up a lot of space. Well, it could always be sent up to you in a cargo resupply mission, right? After the fact. But sending cargo to the ISS is very expensive. And the figure I saw for 2020 was $10,000 per pound. But what's the other issue with doing that? Well, it takes a very long time to get to you. There's no prime delivery to the ISS just yet. So of course, 3D printing to the rescue, right? Back in 2014, the first 3D printer, which was an FDM printer similar to the one that I have, was sent to the ISS as part of the 3D printing in zero-G technology demonstration mission. This printer was developed by Made in Space Incorporated, and its print dimensions were between 2.3 inches by 4.7 inches by 2.3 inches. Essentially, it could print something the size of a large candy bar. And the print time on this printer can range between 15 minutes to 1 hour, of course, depending on the size and complexity of the model that they're looking to print. And here, pictured in the back, see the printer as it was encased to be loaded on the ISS. And so here we actually have an example of something that was printed in space. On the left picture there, we have NASA astronaut Barry Moore holding a Ratchet Wrench, which was created in 2014 with the 3D printer aboard the ISS. And that same model is the one here rotating on the right. And actually, I have that same model that I printed at home. And you can print this yourself if you have a 3D printer or access to a 3D printer. All the files and models that NASA has available are available to you at no cost. I've included a link at the end of the presentation to where you can download all the different models, whether it's this tool, other one that I'll be talking about later in the presentation, as well as 3D models of like the Perseverance rover, the Ingenuity helicopter, and so forth. And then in the middle picture there, we also have the European Space Agency astronaut Samantha working on the 3D printer aboard the space station. And then, of course, the model that I just showed, both in my hands and rotating there, is that wrench. And the story goes that Barry Wilmore sort of complained over the comms that he needed a tool to accomplish a certain. And so the folks at Made in Space became aware of the situation, modeled this wrench, and then emailed it up to the ISS. And within 2 hours of emailing that file, this tool was printed and physically in his hand on the international. So in essence, that story helps encapsulate what the power of 3D printing is, right? Just having an idea and then making it into a reality. Going further in the journey of 3D printing space, we have in 2016, the second 3D printer, also an FDM printer, was sent to the ISS. This was part of the additive manufacturing facility that was sent up. This was also developed by Made in Space. The dimensions for this printer were a bit larger. So this one was 6 inches by 6 inches by 6 inches. And it was actually used to print an antenna part, an adapter to hold a probe in an air outlet on the station's oxygen generation system, and a part to connect two spheres, which are free flying robots used for research on the space station. So this printer actually helped produce a bunch of what we call functional prints. Prints are, I will admit, in the first couple of years of owning a 3D printer, I printed a lot of trinkets, and they were really cool to have and have on my desk, shelf, and at my desk at work. But it wasn't until maybe a couple of years later that I started to learn how to model things myself. And that's where the real value of 3D, right? Being able to solve a problem. So if a particular piece of some equipment at home broke and it can be replaced in plastic, if I have the capability of modeling it properly and printing it, then I can replace that piece without having to purchase another one or anything in between. So again, very powerful technology to have available on a desktop, even more so in space where resources are very limited. Here we have the AMF, right? The Additive Manufacturing Facility, as it was aboard the International Space Station. I've seen it described as a large microwave oven, which I can certainly see how that's applicable here. And on this middle picture, you can actually see this model on the right, which I also have 3D printed here next to me. But there it is floating in space on the print bed in the International Space Station. And this particular model is called the MultiPurpose Precision Maintenance Tool. It has a number of important tools which allow an astronaut to complete tasks with comfort and ease. As you can see, the model itself has ridges on the side for grip, but then it has all these different size openings for different nuts and bolts. It even has a ruler on the other side. And the genesis of that tool actually came out of the Future Engineers 3D Printing in Space Tool Challenge. This was a challenge that was developed to provide students with access to NASA's first 3D printing in zero-G ISS technology demonstration. And in 2015, the winners of this contest or challenge were announced. The teen winner was announced to be that same tool designed by Robert Hillen. And that tool was printed in the summer of 2015 by the astronauts on the ISS. And you can see there in the picture to the right, there is that same tool on the International Space Station after having been printed. So there are current applications with a lot of future implications for 3D printing in space, right? There's a wide array of possibilities that this technology can offer us today, and that can be applied to space exploration and even more importantly, occupation missions, both on the moon and on Mars. So currently today, there are fashion lines that are 3D printing clothes as an example. But of course, with all the limited space on these missions to go to the moon and Mars, there would be thoughts to be had around 3D printing things that you would not necessarily need to pack then, right? Things like clothes. There's also technological advances in 3D printing lithium battery circuits and habitats. So I actually included a picture of a Zillow listing out in Riverhead, New York, that is part of history. This is the world's first 3D printing home for sale. And it's actually for sale currently. I took this screenshot just a couple days ago. But we are 3D printing homes today on Earth, and the idea is we can use that same technology to explore or occupy the moon and Mars, but then use local resources, right? There's some technologies that are being looked into to use the moon dust and rocks and convert that into filament that can be used for printing a base station on the moon, as an example. And of course, the possibilities certainly don't end there. There's a wide array of things that could be done with this technology. So with that, I do have some resources that you can take away. I alluded to this a little earlier. On this site here, you can browse all of NASA's collection of 3D models, some of which have been optimized for 3D printing. And they include some of the Mars rovers that you can print in pieces and then assemble, or even like a crater of the moon. So I actually took, I don't know if you can see it, it might be too bright considering it's white filament, but this is a detail print of a crater on the moon. It can be a teaching setting, as an example. So this moon crater print, the wrench that we saw earlier, and even the tool that won that challenge, all of these models are available on that same link and website. So you can take a look there, 3D print it, include it in presentations, as you saw. I only recently discovered you can include 3D models in PowerPoint, and I've certainly been taking advantage of that. And then the other resource I added here is a link to thingiverse.com. It's a website dedicated to the sharing of user-created digital design files. So on there, you can find a bunch of NASA-related things, or even that pi symbol that I showed earlier, all available there. So with that said, certainly ample time for questions and answers. And I've also included my QR links to both my NASA bio, where you can submit a contact me request there, and also my Instagram in case there's anything that you want to ask or just follow. By all means, feel free.
And I know that there's also people who will help you create those files, which is really neat as well. But there's so many passionate people out there with this as a hobby and turning it into actual job. So it's really neat, all the things that we can do with technology and how you can actually have it at home now, which definitely was not something that was true a few years back. Unless you
Oh,
had a lot of resources and space and know-how.
absolutely. And that's again, going back to what I love about 3D printing. I mean, the printer is just sitting there right next to me and ready to print the next thing. And I just think it's incredibly powerful. There's a certain power that you get from being able to what they call rapidly prototype things. So if I come up with an idea that I think may or may not be a hit, I can go ahead and model it, 3D print it for a fraction of what it would cost to go to real production in injection molding, and being able to test it there. See, does my idea make sense? Do I need to tweak things? And I can go ahead and do that. And it's a lot quicker and cheaper than having to go and do it the old manufacturing way. So
Yeah.
it's definitely, there's definitely a power there.
And I know that we saw some amazing things during the pandemic with people making ear sabers, which our machine was used for, and what they're doing with prototyping for hands. Yep, yeah, I saw a lot of those being made, and it's just such an amazing thing that we were able to take technology we had and teach people how to make those and really make them more readily available before actual production could get up and running. And that a lot of volunteers across the state, the country, and the world, turned to that, something that they were passionate about and turned it into something that was good. And all the things that they're doing for prosthetics and robotics and just fixing things around your house when you can't find that little piece of something that broke off. But it is kind of cool that you've set the Raspberry Pi up that you can watch the progress, because we've walked away from the machine before and something happens.
Mhm.
You don't have that awareness because you get distracted and do something else. But it's a really cool other technology solution to fix something that you clearly did have happen and that you didn't want to have to deal with that in the future.
Oh yeah, no, that Raspberry Pi was a game changer for me. Just being able to step away from the printer, because otherwise, I mean, my main computer would be tied up. I don't want to really mess with it while it's done. The printer will do. So if I could have this little computer just take care of that for me without holding me up on my main machine, then I'm all the better for it. And again, to what you said, being able to see it in a camera, and periodically see, hey, does it look fine, or is it starting to look wonky? Did I screw something? Did I not set something correctly? I can go ahead and save all that time and filament and just cancel the print right then and there, as opposed to having to do it after the fact and be very disappointed hours later when it didn't print correct.
David has a question. What's the cost of the printer and filament? And that's a very diverse and interesting question that I know that you can take the lead on.
Thank you for that question, David. Printers today really can range anywhere between, I would say, for a nice, decent machine, maybe even $200, all the way up to, sky's the limit, really. There are a lot of Facebook groups dedicated to 3D printing, or even Reddit, where you can ask, what is a good starter printer to look at and get started. And I think typically they may recommend something in the $200 to $300 range just to get started, get familiarized with the technology and the different aspects of it. Because there's a lot that I didn't go over today, just because there's so much where, is the bed level? Now, what does that mean? How do I do it? There's a whole bunch of other stuff around E-steps, which is just how the filament is fed through the extruder. But going back to your question, 200 to 2,500 can be a range for at-home 3D print bay. With regards to the filament, I think typically what I've been seeing is maybe between $20 and $30 a spool, which can be a couple kilograms of filament. And again, that all depends on the type, right? We went over fancier types of filament as opposed to just your basic plastic, but that range is still applicable for that basic type of plastic filament. So $20 to $30 is your typical.
I don't think we have any other questions, Isaac, but everyone will be able to maybe again put your information up on the screen so people can find you. And he is really responsive to emails and everything, I promise. But yes, we're excited to have you for something possibly in the summer, Isaac. And for other events that are going to be here for Maker Month, we celebrate New Jersey Makers Day here at the East Brunswick Public Library all the month of March. You can visit ebpl.org/maker or just follow us on social media here, YouTube, Facebook, Twitter, Instagram. So thank you everyone for coming. And for those of us watching later, totally thank you for coming and watching on your own time. Bye, everyone.
Take care.